the next type of integral that we are going to see is the integral of the form 1 upon a sine 2x plus b cos 2x plus c. So once again here a, b and c are some constants, and the denominator contains the sine and cos term of the same angle, which is 2x, right? Now of course it is not needed that all the three terms shown here are present in the integral. It may happen that only the sine term is present and the constant term is present, or maybe only cos term and sine term are present, and so on. So just to take the most generalized form, we are considering all the three terms. Now to solve the integral of this type, the standard technique is that we have to substitute tan x as t. Now let's see why and how tan x is related with this particular expression. Now when we put tan x as t, first of all we'll get sec square x dx equal to dt. This we keep ready for the substitution. Now if we consider the sine 2x term, we know that sine 2x can be written in terms of tan x as 2 tan x upon 1 plus tan square x, right? So we wrote sine 2x in terms of only tan x. Similarly, cos 2x can be written entirely in terms of tan x as 1 minus tan square x upon 1 plus tan square x. So you see, after substitution we can definitely substitute sin 2x as well as cos 2x terms in terms of the variable t, right? Now what happens to dx? How do we substitute it entirely in terms of t? So for that, from here we get dx to be equal to dt upon sec square x, isn't it? So that further gives us dt upon sec square can be written as 1 plus tan square x, and therefore we get at the end dx is equal to dt upon 1 plus tan x was the t that we had substituted for, so we get dt upon 1 plus t square. So we see all the terms in the original integral can be completely substituted in terms of the new variable t, and hence we can simplify the integral using one of the standard forms to which this new integral will get reduced. Now similar to this there is another form. The only slight difference is that instead of angle 2x, here we have angle x. So the only difference is, in the previous sum we had put tan of x as t, so here we will put tan of x by 2 as equal to t. Now because of this substitution, the expressions for sin x and cos x will not change, simply because they are nothing but the double angle formula. So sin x can be still written as we have seen here, it's 2 tan x upon 1 plus tan square x. But since this double angle relation does not change, although the angle changes, so therefore sin x can be written as 2 tan x by 2, which is 2t, upon 1 plus tan square x by 2, that is 1 plus t square. And cos x can be written as 1 minus t square upon 1 plus t square. The only difference in the term is in dx. So instead of dt upon 1 plus t square, it turns out to be 2 dt upon 1 plus t square. So we have to remember this particular change as compared to the previous format. That's the only difference. All the rest of the terms are exactly same. Now let us solve one question based on this type. Here we have to evaluate integral of 1 upon sin 2x plus 3 cos 2x plus 1. So as we know, the angle we observe is 2x, so therefore we must substitute tan x with t. Alright. Now we already know what is to be substituted for sine 2x and cos 2x. So therefore let's directly write the integral I as 1 upon. Now sine 2x is 2 tan x upon 1 plus tan square x. So that is 2t upon 1 plus t square plus 3 into cos 2x is 1 minus t square upon 1 plus t square, because it is 1 minus tan square x upon 1 plus tan square x, plus 1 as it is, right, multiplied by dx is nothing but dt upon 1 plus t square, right. So now if you observe, the first two terms have the same denominator, which is 1 plus t square, and incidentally that is also the same denominator for dt. Okay, so if you multiply the entire bracket with 1 plus t square, we can observe that in the denominator what remains is 2t plus 3 into 1 minus t square is 3 minus 3t square plus 1 gets multiplied with 1 plus t square, so that is 1 plus t square dt, right. So this in turn gives us 1 upon, the constant terms are 3 and 1, so that is nothing but 4. Then the term in t is 2t, so that is plus 2t, and the square term is minus 3t square plus t square, that is minus 2t square, right, dt. Now if you observe, this is of the form of 1 upon quadratic in the variable. So we solve that by first making the coefficient of quadratic term as unity. So let us take minus 1 by 2 common. So therefore we will have t square minus t minus 2, right, because effectively we are taking 2 common, times dt. Now this will get simplified as follows. Here we have minus 1 by 2 integral of 1 upon, we have to complete the square in the denominator. So for that, as we already have t square minus t, to complete the square we need plus 1 by 4, isn't it? So therefore we must also subtract 1 by 4, and we already have minus 2. So simplifying that further, we have minus 1 by 2 integral of, here it is t minus 1 by 2 the whole square. Now minus 1 by 4 minus 2 is minus 9 by 4, which is nothing but minus 3 by 2 the whole square, right. Now this is of the form 1 upon variable square minus constant square. So once again we use the standard formula, that is 1 upon 2a, so that is 1 upon 2 into 3 by 2 log of mod of, here we have variable minus a, that is t minus 1 by 2 minus 3 by 2 whole upon t minus 1 by 2 plus 3 by 2, that is x minus a upon x plus a plus c, right. So that further gives us 2 gets cancelled, 2 into 3 is 6, so that is minus 1 by 6 log of mod of. Now minus 1 by 2 minus 3 by 2 is nothing but minus 2, so here we have simply t minus 2, and here we have t minus 1 plus c. So therefore at the end, in the last step, we must resubstitute t with what we had substituted for. So t is nothing but tan x, so therefore that gives us tan x minus 2 whole upon tan x plus 2. sorry, tan x minus 1 plus c. Well, actually it is 3 by 2 minus 1 by 2 should be plus 1. So answer is tan x plus 1 in the denominator. So that is how we solve this type of integral, by putting the substitution of tan of x as t.